So what we have here is an emergency light. One of your older types, it's got a nicad battery in it. So currently it's powered up, so it's a maintained light. So while it's got mains on it, the light's on, and when you turn the power off, it keeps going because of the battery in here. So what I'm going to do, turn off the power, so, and you saw it briefly dim. So now it's running off battery. So we don't need the mains anymore. So I'm going to remove that wiring and then make it all safe. The other end of this cord is unplugged, so you're not going to cause problems. So now it's running off battery, like so. Unplug the battery, I'm pushing on this clip, I'm pulling. Now this is hinged over here, so normally during installation it arrives looking like this. Loud noises. You got this cover with 2 screws. It sits on it like that. You undo them, it comes off. To get it open, push sideways on those tabs, and the gear tray flips out. Very nice. And what we have over here is the electronics. So there's your power on LED. Let's see if we can zoom it in a little bit. There we are. This over here is a nicad battery. We don't do things like that anymore with nicads. These days they use lithium-ion batteries. So there's your power on LED, and here's your output to your LED panel over here, which has your LEDs. And this is LEDs only. There's no resistors or anything on it. So what happens on here is power comes in, it goes through filtering, Henry's current limiting, there's your class Y decoupling capacitor, there's your rectification smoothing, and it has got mains present detection, which is this section over here. So there's a diode, there's some dropping resistors, there's a smoothing capacitor, and then there's another resistor on the output of that which feeds a diode to this opto isolator over here, which lets this circuit know that there's no mains and it needs to run the LEDs off the battery. And when there is mains, in other words this thing is turned on, it runs it off the mains. See that there is furthermore an opto on the other side. That is probably the feedback for the converter over here, which would be a typical flyback converter. Then over here your output circuitry, which by the looks of things has some switch mode stuff in it, because I see an inductor there. There's a 220 microhenry inductor, and there's the, this is tiny, there is the rectifier diode on the output of the switch mode, and there's a smoothing capacitor on the output of that, and that goes to the LEDs. So hence you don't have any ballast resistors on the output of this to the LEDs. It's a constant current source providing the LEDs with power at switch mode. That is a more efficient way than doing it off ballast resistors straight off the battery. You don't waste energy heating resistors. There is a little bit of loss through that rectifier diode, because this is an asynchronous converter. So the current through that diode does warm it up, and that's where your losses are. So typically your efficiency of a circuit like this would be about 75% versus a synchronous rectifier, where a second control switch does the job of the rectification and you don't have losses there. You can gain close to another 20% in efficiency by doing that, but there's quite a bit more complexity to it, and it's generally not worth a squeeze for the price and extra component count and that sort of stuff. And asynchronous thing works just fine. 75% conversion efficiency is pretty good generally. When you get to high powers, that extra efficiency becomes a goal, and that's where that sort of stuff starts happening, but not at these low powers. So that in a nutshell is going to be it. Power comes in here, does a place for earth, and this does its thing. Now when you reconnect it like this, nothing happens. It doesn't power up. So what you need to do is connect the mains, and then it runs. Of course, we're putting it in storage again. I'm going to disconnect this. Now these days with the lithium-ion batteries, we don't have to worry about memory effect on the battery, where with these you would fully discharge it on a discharge cycle to prevent the memory effect where dendrites grow because of partial discharge, and you lose capacity of your cell effectively over time. If you do that with a nicad, they didn't like it. That was one of their shortcomings that lithium ion has fixed, is that you can partially charge or partially discharge them. In fact, they prefer to not be fully charged and then fully discharged. So shorter cycles at lower currents are better for lithium ion batteries. Nicads were different, pretty different, but two problems: the memory effect and the fact that they contain cadmium, which is a heavy metal which we want to keep out of the system. So their use has become very limited. It's actually become an item which is largely unavailable these days. So that is the story with this light. It is a Knightsbridge. I'm not sure which country that's from. It's possibly British made, with a name like Knightsbridge. It's nicely made. I like the way the gear tray flips out like this, and it's on springs to help it open with the tangs. The waterproof rating, what do they say? IP65, voltage 230 volt 50 hertz, so it's intended for European use. Color temperature 6500K, so it's a fairly cold white. So that's it. Loud noises, like so. After installing it, oh, there was a grommet, it came with this. So after installing it, you just pop the cover on like that, and you're done. That's it, ready for use. 2017. Yeah, that battery might be getting old. I've never used this. This has been in storage for some time. It's typically found in hallways and public spaces where you need permanent light, but they're useful at home as well. If there's an area where you need permanent light, you would install one of these, and when there's a power outage, you've still got light. Generally, but for public spaces, your egress areas and emergency exits tend to have these types of lights, so that's what they like inside. And it has become time to wrap this video up. We've had our talk about this. Nicely made. It was given to me by somebody, and I'm now taking the opportunity to have a look at it. Thanks for being here, ladies and gentlemen. Take care. We'll see you next time for more stuff to take apart or build. Take care, everybody. Thanks. Cheers.